Okay, I think we're back up again. It's on a little bit of a delay. Let's see how much it buffered there before it gets to the present time. A little time travel here real quick. Catch that up. All right, well, you let me know in the chat if that has kind of forced that to restart the stream. And I'll keep an eye on the chats there and grab some coffee. Sorry about that. We're back. And is that on YouTube, Andy? I'm waiting for the YouTube people. Oh, you know, I may need to relaunch the chat window for YouTube just so I can. Back. Better now, I think, says Rolves. Thank you. All right. I'm not sure where that happened during that, so I'm just going to redo the Parsec. Sorry for the repeat on that, but I'd love a clean copy of it. So here we go. Let's do this. All right, for the CircuitPython Parsec today, I wanted to show you how you can adjust the volume of your DAC using an analog potentiometer. So what I have here, if you look on the down shooter, I've got a Feather RP2040, and then I'm running I2S digital audio out to this DAC board, and this is the PCM5122. It's a nice stereo DAC. It gets digital audio over 3 pins, and then it can be controlled over I2C. So what I'm going to do is read this analog potentiometer here on the Feather and then use that to send digital control to the DAC so that it can change the volume. Here it is in action. Oh, hold on. Maybe it wanted, oh, I muted it. Okay, there we go. So here it is in action. I'm going to go ahead and go from essentially negative 60 dB all the way up to 1, or to 0, which is full sound. And I'll turn that back down. So the way this works, in the CircuitPython code here, I'm importing some libraries, time, board, so I get pin definitions, analog I/O so that I can read the potentiometer, bus I/O so that I can set up these buses for I2S and I2C, audio core and the audio bus I/O for playing back my audio, and then the library for this particular DAC. Then I'm setting up I2C, I am creating the DAC object, and I am unmuting it, which I got confused earlier and muted it. Then I'm creating a pot object for this little knob here, which is analog I/O reading on board A2, and that has 3 pins, so we've got ground, positive voltage, and then essentially the divider in the middle, which is what we read. I'm setting up the I2S audio as this audio object here with these 3 pins, and then I'm importing a wave file. This is streetchicken.wave, and I'm creating the loop of it playing, which is audio.play, the name of the wave, and then loop is true, so it's just going to keep playing. I then have a convenience function here, which is called pot to dB, which takes the raw potentiometer 16-bit value and turns that into negative 60 to 0 decibels, which is what we're going to feed the command on the DAC itself. And then I have a state object so we can keep track of when we move it or leave it alone. In the main loop here, we go ahead and first grab the pot value, then turn that into decibels with that function up above. And then if that is different than the last time, if that's changed, we set the DAC dot volume dB to be whatever that number is in decibel, right now negative 60, on the left and the right channel. That's why it says dB twice here. We print that out and then we reset our state variable. So you can see here, as I go up to 0, and then back that off, and eventually a digital DAC volume. And that is your CircuitPython Parsec. All right. Well, hey, the second take is always a little neater than the first, right? Thanks for putting up with the buffering. I'm not sure what was going on there, but it looks healthy again. Cross fingers, knock wood. All right, next up, I'm going to jump over to my browser here, and let's go to the Learn guides. So up in the main menu here on Adafruit, I'm going to click Learn. And in the New Guides section here is this one key Bluetooth keyboard that I built and have talked about for the last couple weeks. I just finished the Learn guide a few days ago. It just got published. And so I just wanted to go over it a little bit with you. So here's the main page. I've got image. I've got a little movie of it in action here, so you can see it flipping between some web pages, and also a GIF of that sort of thing. So I've got a little mention of the features here. So this is a Bluetooth HID keyboard, which can send any of the HID keyboard stuff. So a key, a combination of keys, a string plus a key like a command plus enter, as well as media keys for playing and pausing or changing the volume or muting. This uses the ESP32 CircuitPy, which has a non-volatile storage in it, so we can write settings to it, and those will survive a power down and power up. And it also has automatic sleep, so it goes into deep sleep after 5 minutes, or you can change that to however long you want. This is a safe battery. It just uses a little 150 milliamp hour battery. The interface for adjusting it, since this is written in Arduino, I didn't want people to have to go and recompile it and flash it to make a change like what key it's sending. So I created a serial interface for those things, and the sort of bonus feature on top of that, instead of just having to open up a serial interface and typing things in, is I created a web page, and I demonstrated that a lot on the last show, so you can go back and check that out if you're wondering what that's all about, and I have some images in the guide. So here's the parts you'll need: CircuitPy, the BFF for Neo key, gives you a little mechanical clicky key switch. You want a key switch, some keycap, and then the LiPo charger BFF as well. Battery, and then some headers, and I also used some magnets to hold the case together there, so it snaps together with magnets. This is really the trickiest part here, is this somewhat unconventional stack up to keep it as small as possible without using our usual stacky headers, which are quite tall. So we've got the short female headers that go on the LiPo BFF. We've got the short male headers that go on the NeoKey BFF. And then we are going to create a outside of the pads connection using the little castellated pads. So they have connectors for sort of surface mount, but we can abuse that a bit and connect to the sides of them. So that gives us this nice little stack here. See that there? That's the nice little stack that's inside. And you can still pull them apart. So next I've got a page on the Arduino IDE setup, just how to get the ESP32 board definition stuff you need on there, as well as some libraries. And then here's the page on coding it, so that'll give you all the details on what settings to use when you compile in Flash. Make sure you've got the right libraries there, and then the settings that you'll use when you upload to the board. And here's the code itself. And then I've got a little description here of some of the main features of how the code works. Then we've got 3D case. So I provided, if you're curious why do we provide these different files in the 3D print section, so traditionally we've given you STL files, which are a triangulated mesh of polygons, difficult to edit, but it's exactly what your 3D printer wants. No nonsense, it can print it. Very difficult to edit those, however, so I included the step file, which is the NURBS or NURBS and solids, which looks like that rendering right there. So minimal geometry and a lot of CAD and 3D modeling software. You can open that and make meaningful adjustments to it without having to hack at lots of mesh vertices. And then we've started in the last, I don't know, couple of years, I think the Rees brothers started using slicers that have the 3MF file format, and so that's what this orange one here is. I'm using Bamboo Studio, so in that file you get not just sort of the raw parts of the STL, but you get the model file as well as their placement and orientation on the 3D printer bed or beds if you're doing multi-print bed setups, as well as all of the print settings. So we don't have to include every little detail. It's actually in the Learn Guide, it's actually embedded in that file. So I printed this at a rather fine height, probably finer than I needed, but it really makes all of the interior parts that fit very precisely in here work. So let me pull this open. It's not the magnets that are that tight, it's the little 3D plastic pegs there. So if I open that up, you can see I've got a pretty exact fit for this stuff, and the Neo key, mechanical key switch snaps in there. Also, I've got a little toggle there to extend the on-off switch, so we didn't have to add a separate on-off switch. All of that stuff wants to be fairly precise, so that's why I included a 0.16 value there on the 3D print. So those are your settings, those are the parts. I used a little bit of tree support to keep that little arch there from collapsing, and same with one bit on the other side for where the key switch snaps into. And then we fit it all in and insert magnets. You just want to be careful about your orientation on those. So I fit 2 of them in and then set the other 2 on top, flip it over, squish it, then you know you're not going to have a magic levitating case. Just gonna squeeze those in there with some parallel jaw pliers, and put in your key switch, put in your power switch, close it up, and put on your keycap. Ready to go. You can also mix and match colors. You can, if you don't have a multi-filament printer, you can print just the base, then just the top, and have a couple colors, like you see that yellow and blue one back there. And then here I've got again the little video there of it in use. I'll go ahead and play that. You can just see I have that. Turn off the volume there. I have that connecting up to this laptop, and then I'm cycling tabs in the browser with it, which is kind of a nice use for it. You can also use this as like a page down if you just want to scroll one page at a time of a big PDF document or web page. It's another nice use for a little remote like that. So here I show how to do your Bluetooth pairing with the device, and then these are the serial commands. So if you open this thing up in a serial, like the serial monitor in Arduino or some other serial application, you can then just simply type in, if you type in a Q, this is now gonna type Q. If you type in a special key or a string in quotes, you can use this syntax here. So control the plus sign Z, hit enter in your serial terminal, and now you've turned this into an undo button. However, as I say in the guide, this started to get out of hand as I added more and more things, and I didn't want to just have a big cheat sheet for it. And so that's when I created this web page here. So here you can see this has web serial. You'll need to use Chrome or Vivaldi or Edge or something like that that has web serial. Plug this into that computer, connect. This is not wireless. Connect over USB, and then you can do all of those serial commands with a nice GUI, including setting the color of the NeoPixels, the brightness of them. As you can see here, if I turn this back on, I have a blue color when connected and a sort of yellow when I press. So all those colors can be configured inside of here. Set your sleep timeout, and there's also a little log here of the serial output. This just goes into detail of all of that stuff, and there's the code for that web page. And then I, thanks to Tim, Foamy Guy just helped me migrate over. I had set up a GitHub pages on my own GitHub. He created a repo for that and moved it over, so there's now a hosted page if you don't want to just launch the index HTML on your local machine, or if you don't have it and you're somewhere wanting to change this, you can always plug into a computer and then click this right here, the one key web serial configurator. I'm in Safari, so it's yelling at me about that, but this is adafruit.github.io/onekey-keyboard, and that will take you right here. I can plug in and connect now and use that. But I did that last week on the show, so I won't go over that again. And is that it? Yeah, that's the bottom of the page. That's the end of the guide. So go check that out if you want to make your own. And I will, I really like to give credit. So this was inspired by this monokey project on Kickstarter, which I don't know if it was open source. It may have been, but it was a limited number. I think they made 500 of them, and so if you wanted that and missed out, this is maybe a thing for you to look at to make a sort of inspired by version of that. All right, that's the Learn Guide. So the last thing I want to do is go into, I'll head over to the workbench and go into this new thing, which is sort of a new old thing, and I mentioned this on Show and Tell last night. Fruit Jam, which we've got all sorts of cool software running on this, including some great emulators like NES emulator, the Pico NES, multi-format, Genesis, Macintosh, and so on. But one thing we did not have was Pico-8. And in fact, before I head over there, let me show you Pico-8. I'm gonna go back to the browser here. So Pico-8 is at Lexalawful Games, lexalawful.com, but just search for Pico-8. This is the Pico-8 Fantasy Console. So Pico-8 is just amazing. It is a sort of feels like a 8-bit computer that never was. You can load games on it, play games on it, edit those games immediately by hopping right into the code editor for the game that's currently running. It all runs in Lua. And there are, in the version that runs on a computer, not the Pico, or not the Fruit Jam version, but on the version on the computer, there's also a number of editors built in for pixel art, sprites, music, sound effects, and a few others. So we have a limited version running thanks to the Free Willy, Freewili, Free Willy GitHub. You will find the Willy 8 Jam, and this is a port of Pico-8 for Fruit Jam specifically. So the joke that Lamore made last night was Pico-8 is the fantasy console. This kind of turns it into a reality console, because once you load Pico-8 on here and put some games on the SD card, you now have a real physical console that you can plug keyboard and mouse or keyboard and gamepad and HDMI DVI video out as well as audio out. So this puts it all onto a little tiny computer, that microcontroller-based computer with the RP2350 that allows you to play some of these games and edit them. It doesn't have the full feature set, but you can use the file browser, you can save games, you can load them, run them, edit them. So let me hop over to the workbench here and do a little demo for you. I'm going to put the main cam view over there, and let me head over. I'm going to turn this off just so that I'm not blowing the air conditioning right at the mic up above me. Okay, so I'm going to turn it off. So here's the Fruit Jam. Let's pull it all apart. So let's see everything that goes into this. My monitor's not happy about that. So Fruit Jam, there's the SD card. This has some P8, Pico-8 format games on it, and applications, little demos. This also has some other stuff on it, so you'll see when I list some NES and other game stuff from a different emulator I was using that card on. So I'm going to give this HDMI-shaped DVI video out, which my monitor will gladly accept. And audio out, I'm just going to a little powered speaker over here. Here is a keyboard. Here is an Xbox 360 controller. And there are a number of different controllers that will work on this, but this was the handiest one I had. And I'm going to go ahead and give it power. You should see my monitor woke up pretty quick there, and this says Willy 8 Jam 0.10. Tells us how much PS RAM we have. It has identified the SD card. It says audio is ready. The whole thing is ready. So now it immediately accepts keyboard commands. So I can type in, let's do clear screen, CLS, and then I'll do help. Oh, and let me check let me bring up my Discord just because I heard a Badoop come in. Make sure that we're still broadcasting healthily. Oh, it looks like we're buffering again, huh? It's obscured by my window. Oh, it totally is obscured by my window. Sorry about that. Let me make that a lot smaller. Oh, there we go. Okay, it is happy again. I just restarted it. Okay, thank you for the note. Who let me know? Andy Calloway. My window was totally in the way of the fruit jam there. Sorry about that. Let's go back to that view. I just made the main view smaller. That looks better. Okay. Keep an eye on that streaming health icon. So I'll turn that back off. Yeah. So there's the setup for it. Basically, we've got Fruit Jam. We've got SD card there with some P8 files, the game or application files. And then I've got HDMI-shaped DVI video. I've got stereo audio, USB-C for power, little keyboard, and there's the Xbox 360 controller over USB. So just power that on. There we go. It launches up, and we can do info, and that'll tell us, okay, this is the Willy 8 Jam on Fruit Jam with the RP2350 processor running at 252 megahertz. It lets us know the PS RAM, and then it lets us know what USB has enumerated here. We've got a keyboard. We do not have a mouse. Controller 0 is an X input controller, which is like a Microsoft controller. It says generic. I'm not sure why. If I type in help, it'll let me know the commands. So this is a subset of what you've got on the full Pico-8 running on a Raspberry Pi or a computer. So these are the commands you can do. You can load a cartridge in, which is the P8 format file. You can save a cartridge. You can run a cartridge. You can list your directories. You can change directories, make directories, remove files, clear the screen, edit a cart, run a reboot from here, and then info and help. And you can get more help on a command. I haven't tried this yet. Let's see. Let's do help, edit. Open the code editor, escape toggles, editor terminal. Okay, so yeah, some nice helpful info there. So if I do ls, so list the contents here. And like I said, I've got some Crufton things on here from other uses of this SD card. But a lot of these here that say P8 are the example files that this distribution comes with. So I'm going to run hello. So I'll do a load, and you can give it a full path and file name, hello slash hello P8, or you can just say load hello and it figures it out, and then run. Okay, I'm gonna turn down my audio there. So here you can see we've got hello world, this cool sine wave effect, and echoing in cool colors. Says, this is Pico-8, nice to meet you. So, cool thing about Pico-8, if I hit escape on my keyboard, it immediately shows me the code that's running. So this is hello.p8. Let's see if there's anything obvious I can change on here so that we can see this in action. You know what, let me do it to a, yeah, okay, let's change the text. That's a classic. Instead of this is Pico-8, I'll say this is Fruit Jam. I'm gonna hit escape to get out of the editor, and then I'm just gonna save this as a new hello. So save hello to, and I'm gonna load it, make sure that's the one in memory, and then run it. This is Fruit Jam. You can see it has some justification that was hard coded, so it doesn't quite center. But that's how easy it is to go in and adjust things. Now, I would say it'll be a challenge to do graphics on here. This is a little bit more about either coding or playing. This heart, for example, if it even shows up in here, it's going to show up just as like a big, oh, this is a, okay, that's like a weird, I'm not sure how they're doing this. So that is probably a big text block if you were to look at this file on a computer. So I'm not sure what concessions were made here for this on Fruit Jam, but you're not going to be able to go and edit the graphics on here. So if we try another one, let's do bounce. So I'm going to load up bounce, and I will run it. So here we get this nice bouncing demo. And I'm so impressed by how fast this runs. I don't know if there's an FPS counter you can do, but this is running great. Look at this one, has a controller input that forces this thing to kind of impel upward. Bouncing all around. So if we go and escape in here, let's just change where the floor is. Let's make it much higher. So this has a 0 index at the upper left corner in the screen. So if I move this up to, let's say, 50, that should bring it up closer to the ceiling. I'm going to go ahead and escape. I'll do save bounce 3. I think I have a 2 already. I think I need to load that. Bounce 3. And then run it. There we go. So now we've got a much higher floor on this. And if we take a look at the other demos on here, there's a nice, let's see, which one is waves I've shown before. Dots 3D, what's that one? Load dots 3D. Oh, there you go. Hey, very cool. So a couple interesting things here. The canvas, the working canvas is 128 by 128. So if you're making something for Pico-8, that is it. That is your constraint. In Fruit Jam Pico-8, the authors said it is pixel tripled. So 300, whatever that is, 128 times 3. However, I believe when that frame buffer hits the DVI output circuitry on the PIO of the RP2350, it's actually sending out a 640 by 480. And if I go to this monitor's menu, you'll see down here it says digital input 2 is what's being used. Resolution is 640 480 at 60 hertz, which is great because that's a very standard, like the most standard almost video format you're going to find on monitors. So even though this has a DVI monitor input, or if you have a TV with an HDMI input, very likely is going to accept happily that 640 480, and you can see it's letterboxed. So are pillar boxed. So we have actually both. We have black lines that are sending out a 640 480 canvas, and then we have the 3 whatever by 3 whatever Pico-8 in the middle of it. So it looks great. It's not stretched or anything like that. Some monitors, this is a 4x3 monitor. Some monitors that are wider may need to have a 4x3 setting invoked, and your mileage can vary with monitors, but I've gotten a lot of mileage, especially this last year, building this video wall behind me, out of older, like 10, 15-year-old DVI monitors that have, you can just use a simple adapter to go from a HDMI cable to that DVI DVI-D plug that they have. So you don't have to worry about finding an HDMI input monitor, which is usually a little harder to find if you're looking at just like thrift store stuff. So it's running great on that. And then, yeah, audio out of the DAC sounds great. Let's go to let me do the, let's run Celeste. So if we do load Celeste 2 and run that. Now, Celeste does have these wind noises, so, but at some points those go away. And this is a real torture test for frame lag. So you can't play this game if there's much lag, and I haven't detected any. Woo! Yeah! So this is I don't know what is the deal with this version of Celeste, but it's totally new stuff. And it has a grappling hook. Does the original Celeste have a like grappling hook? Yeah. Wee. So there's Celeste. You can hear the music. Sounds great. Little sound effects on top of the music. Woohoo! All right, let's turn that down. I haven't tried anything with mouse yet. There are some Pico-8 things with mouse, but this is the whole game here. Other features in the editor, you can use page down, page up. So if you want to cruise through your pages quicker, because this is a big program, you can with that. I wouldn't want to code something this big on the Fruit Jam version of it. You'd probably want a separate editor on a computer, but you can. If you have this plugged in, the Fruit Jam plugged into your computer, you're going to get power and the ability to serial REPL into this. And then you can, everything that I'm doing here will show up in the REPL. The game canvas will show up just on the monitor that this is plugged into. So let's see, what else is on here? Load, what is... So this is a version of Waves with the little Free Willy whale. Free Willy being the developers of this port. And what else is on here? Collide. This is a nice little demo of some of the movement, friction, collision. If you're going to do a little RPG game, you might want to look at this for how stuff is done. Whee! Get out of here. And again, there's the program. Wall and Actor Collisions by Zepp, who I believe is the main developer on Pico-8. That is all I got to show on that. So really neat. If you've ever wanted to just play some Pico-8 games on a neat little setup, that's the way to do it. I'm going to write up a little guide on how to get that all set up, and you'll be able to follow along with that soon. Shouldn't take too long to write that up. Okay, let's see. Anything else? Again, thanks for your patience with the stream. I don't know why I was having issues. My bandwidth looked good when I tested it earlier, so I don't know what was going on, but there we are. We've got some nice contributions here to help us understand the issues. There's our gremlins. Here's buffering. Working fine now. Great. Yeah, cool dots, right? Patrick Sharkey 1623. That little waves demo is fantastic. Okay, Tyeth was late to the game, fortunately, just as the stream got fixed. Yay. Yeah, Tyeth, have you checked this out? This Fruit Jam Pico-8? It seems like it would be up your alley. So go check it out. And like I said, I'll write that up. Okay, I will remind you if you want to go and save some money over in the shop, that coupon code is good until midnight tonight. One key. Head on over to the Adafruit shop before midnight tonight East Coast US time, and you'll get 10% off on your order. Just type that into the coupon code slot. Okay, I think we're going to call it right there. Thank you everyone so much for stopping by. For Adafruit Industries, I'm John Park. This has been John Park's Workshop, and I will see you soon. Don't forget to tune in to Deep Dive with Scott tomorrow, Deep Dive with Foamy Guys on Tuesday mornings now. I've got my product pick of the week later on Tuesday at 1 o'clock, 4 o'clock Eastern time, 1 o'clock Pacific time. And then we'll be back with 3 Hangouts Wednesday morning and show and tell. So that's what we've got lined up. Thanks everyone so much. Bye-bye.